So with that, I'd like to close my session and then introduce Erin Pole, who I mentioned earlier. She's a graduate student and sleep technician who's been focusing on the sleep study part of this project. Erin.
Hi, everyone. Thank you, Dr. Kadab. This is my first time being able to present my research to you guys over Zoom, so I hope everyone can hear me. Yes? Okay, well, I'll just continue then. So today I'm going to talk about two parts of the project that I've been working on. The first part is going to be about the comparing Fitbit to the gold standard of clinical sleep medicine, which is the polysomnography or the PSG. Now, these unfortunate people, many of you may recognize this as you've had your own sleep studies done. They are getting the PSG, which happens in the sleep lab. You can see they are wired up from head to toe. We have EEGs on them. We have several sensors on their face tracking eye movements and muscle tone. And they oftentimes have several cannulas in their nose. It's a lot of equipment, and it's required to be, oh, hold on, go back. It's required to be monitored in a overnight in a sleep lab with a technician. Now you can imagine for research purposes, especially with our goals of getting long-term data, sleep data and activity data, it is difficult to convince people to do this every single night so that we can get the data that we need. We are looking for alternatives to the PSG. It's also very expensive because it has to be monitored all night just to make sure nothing falls off. So the gold standard for us is not ideal. If you go to the next slide, this is an alternative that is out there, and you can see these are the home sleep test equipment. It's much less cumbersome as far as the wires and things, but still with this equipment, you are required to have disposables. So you have cannulas you have to throw away every night. A lot of the pieces have to be replaced periodically, and it is very expensive. I mean, some of these can go, you know, $1,000, $1,500 per unit. So when we have over 100 people in our study and we're tracking their sleep, it can get, you know, the cost does play a factor in whether or not we can use some of this equipment. Next slide. So the alternative that we found that we thought would work great for our subjects is the Fitbit. And many of the activity trackers do this now, where they can track your sleep stages and along with all your other activity. The issue with the Fitbit is that, as you can see, it has a lot less wires and things connected to you. Typically in a PSG, we're using your EEG and your brain waves and then your muscle tone to be able to detect sleep stages. Well, with the Fitbit, it only has it's tracking your movements, so it knows when you're moving and when you're still, and then it's also tracking your heart rate, and it's determining your sleep stages based on the variability in your heart rate. So it's a very different sensor and reading altogether. So what we wanted to know is how good is the Fitbit at detecting the sleep stages that are also detected during the PSG. So if you look at these graphs here in the middle, now this is the activity that we're tracking on all of our volunteers. If you guys don't know, Fitbit tracks all of their activity during the day and then also their sleep activity at night. What we get when we're looking at sleep data is this graph here called a hypnogram. And this x-axis here is your time. So it starts when you fall asleep or when you lay down to go to sleep, and then it ends when you wake up. And throughout the night, you're going to cycle through all of these sleep stages. Well, the orange line here is the Fitbit, the stages that the Fitbit thinks you're in. And then the blue little dots that are kind of connected here, they are, we had two sleep technologists score the PSG for this person. And then we compared, and wherever the Fitbit and the two sleep techs agreed, we put this blue line. So when we did this originally, it was on one person. We did about 5 or 6 nights. And what we saw was that the Fitbit was pretty good at detecting sleep stages, but there were still some discrepancies. You can see here, the Fitbit thought that the person was in REM, and neither one of the sleep techs thought the person was in REM here. And then you can see here, it kind of missed a few of it thought it was still in REM when the techs thought it wasn't. So we saw this and we thought, okay, we have a cohort of people who are all older, who have a myriad of health issues, who a lot of them have sleep disorders. How good is the Fitbit at detecting sleep stages for those people, and not just your, really healthy subjects that are in the previous work that was done for comparison purposes. This Dream device here is another one I've talked about it before, I think. So we were also thinking about doing this. This one has an EEG, so the sleep staging would be more comparable to the clinical PSG. But again, this device is, this is about $500. So these devices that will give us the best data are not necessarily things that make sense, on a economic level, or to give them to hundreds of people. It's just so that's why we're using the Fitbits, and we really want to know how good is the data that we're using, or we're getting from them. So if you go to the next slide. So what we did was we had volunteers come in. They were coming in for a regular sleep study, and we kind of targeted people that were over the age of 40, and we asked them to wear the Fitbit while they were getting their PSG done. And then, as is typical with a PSG, we have a registered polysomnographer, it's RPSGT. They will take the sleep study and score the sleep study for the doctors to interpret. Well, we had 2 registered sleep techs go ahead and score this study, and then we compared the Fitbit to those 2 scored studies. We also wanted to look and see that how good the Fitbit was the first half of the night and the second half of the night. We were thinking that Fitbit is very proprietary when it comes to their algorithms and how they handle the sleep data. And we wanted to know if perhaps the first half of the night might be, or the second half of the night might be better at staging than the first half, after it's kind of learned how that person sleeps. So that's why we broke it up into the first half of the night and the second half. So we had 12 subjects that originally agreed to wear the Fitbit, 7 female and 5 male. Their average age was 65. They ranged from 41 to 78. 6 of them had been diagnosed with a sleep disorder already. And there were a mixed bag of people. There were people who were having just the PSG, where we just monitored their sleep. We also had 3 people who were on CPAP, which is the continuous positive airway pressure. You might be familiar with that with the mask. And then we had a couple of people who had a split night, where they had a PSG the first half of the night, and then CPAP the second half of the night. And why that was important is because we are enrolling a lot of people who have CPAP machines and who have sleep disordered breathing. And so we wanted to know, okay, with those people, how good is the Fitbit at really detecting sleep? So one of the first things we noticed was, out of the 12 people, 4 of those people did not track any sleep at all with the Fitbit. So if you are familiar with how the Fitbit works, when you go to sleep at night, you don't have to start anything. The Fitbit will detect when you're asleep, and it'll automatically start staging your sleep for you. So when our subjects came in, go back up. I haven't talked about that. when our subjects came up, and we just allowed the Fitbit to start the sleep just like it normally would. 4 of them, the Fitbit did not track any sleep at all. And so when we pulled those people out, what we saw was, there's a indicator for sleep apnea called the apnea-hypopnea index. And not to get too technical, these people had a very high prevalence of sleep disordered breathing. And so compared to the group that it did read the Fitbit data for. So what we can kind of tell from that is that if you are a person who is having, who has a Fitbit and who wears it religiously every night, and many nights out of the week it's not reading it's not reading your sleep, that this might be an indicator that you have an elevated AHI or something going on where you're waking up a lot at night and the Fitbit is not able to track your sleep. So that was the first kind of indication that this might be an issue for some people. So if we look at each individual sleep stage, though, this is a lot of technical words down here. I'm going to try to make it as easy as possible. So we see for wake that the sensitivity here is low. If you look here, this 1 means that it was perfect and 0 means it missed on every mark. What we see here is a lower rate for sensitivity for wake. And what that means is that the Fitbit missed wake sometimes, so that the techs were scoring wake on the PSG, but the Fitbit thought that the person was still asleep. So that gives us an indication that wake may be a little underscored when we're looking at the Fitbit data. The light sleep, on the other hand, had a very high sensitivity for light. But we see here that the specificity is low, which means that it was pretty much scoring light as a if it could be, there was a lot of light. So if it was getting the sleep stages wrong, it almost always erred towards going toward light. So if you go to the next slide, we look at deep here. Now this was interesting because just to understand what accuracy and precision is, if you're looking at a bullseye and you hit the bullseye in the middle, and every time you hit the bullseye in the middle, if you take 10 shots and they all kind of go in the middle, that's a pretty good accuracy and precision. Precision, though, means that maybe you didn't hit the bullseye right in the middle, but you hit it in the same spot every time. And so when you have a low precision like this means that Fitbit really is guessing all over the place when it comes to deep. And this is not something that's like other people have found this in their studies as well, is that it doesn't do a very good job of detecting deep. And what we found was it normally overscored deep more than what the techs were scoring. And then sensitivity and precision on REM was about average. And what we found was that in our work, it was very similar to the other work that's done. And recently they had another study that came out with people who had obstructive sleep apnea. And across the board, what they've said is this technology is not ready for clinical use. I mean, this is not something that a doctor is going to give you and be able to take anything out of it from there. He might get some indications, but he can't use it for diagnostics. So what does that mean for us as researchers, though, is that we take that data that is not necessarily perfect data, it has a lot of noise in it, and we can use it to look at trends over time, because what we're seeing is that even though it's inaccurate, it's pretty consistently inaccurate over time. And so there's not a lot of deviation night to night. And so if we look over time, if you go to the next slide. Oh, this one, yes. If you look over time, now this is one subject from January 1st through May 31st. And so, and this is their REM. So when we look at an average over time and then do like a trend line, we can see that we can get, we're kind of condensing the data in a way that makes it so that if it's a little off one night or another night, it's not gonna make a huge difference. So, this is kind of segueing into the next paper that we're hopefully going to submit next week. This is on activity levels before and after the pandemic, and how the pandemic and the stay-at-home orders may have affected activity. So what we did here was we took a timeline of all of the major events that happened in the news that had anything to do with COVID. And then we looked at these parameters and said, okay, how many people had a significant change in their activity before and after these dates, just to find out which date really made the biggest impact on activity. And what you can see is each activity, most of them fell on March 23rd. This is the day, if we look here, that the city of San Antonio issued the stay-at-home orders. And the majority of the people that are in our study are in the San Antonio area. So we did find that as far as activity goes, that March 23rd was a pivotal date where we did see more people have changes in activity. And if we go to the next slide. Okay, so then we take, what we did was we took not only their averages, we also took those slopes of the trend lines, and we used those to group people into clusters. Now this is called cluster analysis. Where we take all of the data for everyone and we kind of put it all together, and we say, okay, we use an algorithm, who is the most similar to each other according to that activity data. So these people are clustered solely on those metrics that I showed before, the steps and the REM duration and so on. So we put them all into groups, and we said, okay, for each activity, what is the profile for this group? So for this graph in particular, this was change in REM duration before and after that date. So we can see group 2 here had a high percentage of change where they increased their REM duration, and group 3 had a high percentage of decreasing the amount of REM they are. So what do we do with this information? Once we have it, we pull out the demographic and the health data that you guys have filled out, a lot of you who are in the study, those questionnaires that we have, and we said, okay, can we make a profile for the people who are in group 2 who, you know, maybe if they have increased REM, what's going on with those people? And then the people, especially the people who decrease the amount of REM, what's going on with those people? And, you know, where can we put them into a group where we can identify some issues that they may have? So this is just an example of some of the demographics that we have and that we're looking at. So for instance, you can see group 2 has a high percentage of people who have high blood pressure, and you know, they also have a higher percentage of REM. So as we're going through, we're correlating these activity groups. Now this is a group that's, you know, they've been grouped together based on all of their activity, and then and looking at their demographics. So in the future, what we'd like to do is use this long-term data to detect diseases such as Alzheimer's disease, Parkinson's, other neurological diseases. And then we could use that activity data to perhaps predict how prevalent that's going to be in that population. And that is the end. I think I don't have any more slides.
Thank you, Erin.